Lesson 10.2.1, problem 10.22. In this problem, we are given the following quadratic equation, x squared plus 1.5x minus 2.5 equal to y. Problem says that Cassie wants to use the zero product property to find the x-intercepts of this quadratic function. She started factoring and then blurted out, and then Claudia blurted out, "No, Cassie, I think there's another way. Can't you first rewrite this equation so it has no decimals? Then it will be faster and easier to factor, and we won't have to use the quadratic formula." So the question is, what is Claudia talking about? And then we want to rewrite this equation so that it has no decimals, and then we will solve this equation by factoring. Okay, so if I can somehow rewrite this equation to get rid of the decimals, then it's going to be a lot easier for me to factor, and I don't have to use the quadratic formula. So I know that if I multiply, so first of all, I'm going to let y equals 0, because if I was factoring it and trying to find my x-intercepts, we have to let y equal 0. So I'm going to do that first. And then I know that if I multiply by 10, that moves my decimals one place to the right. And so if I multiply by 10, my decimals are going to essentially go away. They'll be behind my numbers. And so then I'll have whole numbers that I can work with. So remember, there's a 1 in front of that x squared. So I'm going to multiply everything by 10. All right, so when I do that, that gives me 10x squared. When I multiply 1.5 times 10, right, that just moves my decimal over one place, so I get 15x. And when I do the same thing here, multiplying by 10 moves my decimal over one place, so I get minus 25. And then 0 times 10 is just 0. All right, so now that I have nice whole numbers, I can factor it. And I'm noticing that every one of these terms has a factor that goes, the same factor that goes into each of the terms. So I know 5 goes into every term. So I'm going to factor out a 5. And that leaves me with 2x squared plus 3x minus 5. And then I just need to factor this piece of it, and then at the end, add in that 5 I took out. Okay, so using my generic rectangle diamond for this part of it, I get 2x squares, negative 5 ones, multiply those together to get the top of my diamond. That gives me negative 10x squared. And then in my equation, I have 3 x's. So I'm thinking about those factors that multiply to give me negative 10x squared and add up to give me 3 x's. So those are going to be, let's see, positive 5x and negative 2x. Yep, this will work. All right, I'm going to put those into my generic rectangle. And then I'm going to look for the dimensions of my rectangle. So let's see, 2x goes into both of those terms. That makes this x. And then 2x times negative 1 will give us those negative 2x's. X times positive 5 gives us those 5x's. And this to check, 5 times negative 1 does give me those negative 5 ones. So my area as a product here is x minus 1 times 2x plus 5. And then I need to remember to bring down that 5 that I factored out. And then remember, this is set equal to 0 because now we're going to use the zero product property and set each factor equal to 0. So here I have 3 factors. There's one, there's another, and there's another. So I'm going to set them each equal to 0. Okay, so we know that 5 is not equal to 0. So that is not going to be one of our roots. But I can solve these and see that I get a root at x equals 1, or the point 1, 0. And my other x-intercept, when I solve this one, is at x equals negative 5 halves. And I can write that as a decimal if I would like, so that would be negative 2.5 0. Okay, so if we can rewrite our problem and get rid of the decimals, we get an easier problem that we can factor.